Hi Geometry. We're going to review graphing from vertex form. So first of all, I'd like to begin with what we call our parent function, or our most basic quadratic graph that has not been shifted left or right or up or down. It looks like y equals x squared. So my vertex, when my graph has not been shifted, is at 0, 0. So let's put a dot there. And let's look at how my graph's going to move. So let's make a table of x, y values. Let's plug a 1 in for x and see what my y is. When I plug a 1 into the y equals x squared, then 1 squared is 1. So y would be 1. When I plug a 2 in for x, 2 squared would be 4. So my y value would be 4. Let's just do 3. So when I plug a 3 in, 3 squared would be 9. This is what we call quadratic movement. And we use that to help graph our parabola. So let's go back to my vertex and move 1 unit to the right in the x direction. And then I'm going to move 1 unit up in the y direction. That's this first row's 1, 1 movement right there. 1 in the x direction right and 1 up. Both of those are positive movements in the x and y direction. But negative 1 squared is also positive 1. So we're going to go to the left 1 with our pencil and up 1 to put a second dot. This is creating that U-shaped parabola. So now let's do our 2, 4. Go back to the vertex and count over 2 on the x-axis and count up 4. 1, 2, 3. That's my 2, 4 movement that I wrote in the second box. That's 2 in the x direction and up positive 4 in the y direction. Let's also do it to the left because negative 2 squared is also positive 4. So we're going to go back to our vertex. We're going to count over 2 to the left on the x-axis. We're going to count up 1, 2, 3, 4. So I don't have to do the 3, 9. When I ask you to graph a parabola, I'm going to grade 5 points. I'm going to grade your vertex, I'm going to grade your 1, 1 point, and your 2, 4 points. These are the 5 points you see. When I connect them, I'm not going to make it look like a V. It is loosely a U shape. I realize it doesn't look perfectly U-ish, but it is definitely not a V. You studied V-shaped graphs last year. These were the absolute value function. You want to make sure that you're not making your parabolas look like V's, which was a whole different function. So let me erase that to kind of clear off this area right here. Okay, so what happens when there's a negative in front of my x squared? Well, this negative, this a value, is the direction of my graph. So it affects my y values. So let's take a look at this one. First of all, my vertex is still 0, 0. My x squared has not been shifted left or right or up or down. And so I know my vertex is 0, 0. Let's look at that table, that xy table, for just a moment. And this time it's y equals negative x squared. So this time when x is 1 and I substitute it in, I get 1 squared, which is 1, but now it's a negative 1 because of the negative in front. When I plug in a 2, I get 2 squared, which is 4, but then there's this negative out in front. The negative's not being squared, it's just sitting out in front. So that gives me a negative 4. And if I wanted to plug a 3 in, the same thing's going to occur. 3 squared is 9, but there's a negative out in front, so it's really negative 9. So when I have a value, an a value in front of my x squared, I have to multiply all my y values by it. So because there is a negative in front of my x squared, that's why I have a negative in front of all my y movements. And when I go to graph, this just means my graph is going to point down. So as I go to the right one, I'm going to go down 1 instead this time. Now let's go to the left one and go down 1. Great. That's because there was a negative in front of my x squared. Now let's go back to my vertex and go over 2 and down 2. Oh, I'm sorry, down 4, down 4. I wasn't paying close attention. The bell's going to ring in just a second. Let's go over 2 and down 4. 1, 2, 3, 4. Now we're going to go over 2 to the left and also count down 4. 1, 2, 1, 2, 3, 4. You're welcome to count over 3 and down 9. It would be just 1 square off the graph. But again, these are the 5 points I would grade. And so when you connect them, again, be careful it's not looking too much like a V. This is a curve, it's not a V. So now let's remember vertex form a little more closely. So vertex form, which is also discussed on our page 9 video. So I'm not sure if you're watching this before or after page 9. But vertex form is A times x minus h squared plus k, where hk is the coordinate of my vertex. And because of the negative in front of the h, I have to think the opposite, just like we did with circles. But the k is not in parentheses. There is no minus sign in front of it. So it is just simply whatever the number is. So I am not going to change the sign of k. But I do need to think the opposite for my x coordinate. So now this a, I need a little bit of room. So now this a that's out in front, like we just did a moment ago in numbers 1 and 2, when a is positive, my graph points up. When a is negative, my graph points down. You learned that last year. So we also, this year, will be dealing with a where a is not 1. For example, it's a positive 2 or a negative 2 or a positive 1/2 or a negative 1/2. And we'll go over what to do with that in the page 9 video when you watch it. So let's jump down and look at number 4. So for number 4, this is an example of vertex form, y equals a times x minus h squared plus k, where the number in front of my parentheses is 1. So in this problem, my vertex is not 0, 0, because this has been shifted. The h is my horizontal shift. That's how my x changes. Remember, I have to think the opposite. So it's going to shift to a positive 4. I'm going to go right 4, the opposite of what I see, because it's inside the parentheses with a negative in the formula. But the k is my y change, and the k is whatever I see. So that is a positive 3. So my vertex is now 4, 3. So let's go to the origin and count over 4 and up 3. 1, 2, 3. This is my new vertex. So now let me figure out my table. Your table always starts with the 1, 1, 2, 4, but it has to change based on your a. In this problem, my a value is 1. So I'm actually not going to change anything. I'm not going to multiply by a negative. My a is not negative. And a hint to future problems, I'm not going to multiply the 1 and 4 by 2. My a is not 2. My a is 1. So I have my basic quadratic movement. I'm going to do it just like I did in number 1. I'm going to go to my vertex and go right 1, up 1. That gives me one of my points. That's my 1, 1 movement that you see right there in the top box. Oh, sorry, I thought that I was on my highlighter. I apologize. I didn't mean to cross it out. I meant to highlight it. So now I'm going to do that on the other side, left 1, up 1. And now I'm going to do my 2, 4 movement. I'm going to go to the right 2 and up 4. And I'm going to go to the left 2, 1, 2, and up 4, 1, 2, 3, 4. And that's me doing my 2, 4 movement that you see right here. And so I'm going to draw in my graph. Again, trying to not make it look too much like a V because it is supposed to be my U-shaped parabola graph. So let's take a look at another graph with a negative in front. That would be this example right here. Again, my vertex is going to be the opposite of what I see for my x coordinate, so that's a positive 6. It's going to be whatever I see for my y coordinate, which is my k, so that's a positive 4. And my movement that I always write down is 1, 1, 2, 4. And now I look at my a. My a, which is in front, my parentheses, is a negative 1. So now I'm going to multiply my y values by that -1. So 1 times -1 is -1, and 4 times -1 is a -4. This is what makes my graph point down. So let's go find my vertex, 6, 4, 6 to the right and up 1, 2, 3, 4. And now I'm going to do my 1, -1. Let's go right 1, down 1. Let's also go left 1, down 1. Let's go back to my vertex, and I'm going to go right 2, down 4. 1, 2, 3, 4. And I'm going to go left 2. 1, 2, down 4. 1, 2, 3, 4. And I'm going to softly draw in my curve, again trying not to make it look too much like a V. So let's look at one more really quick on the next page. So if I flip to the next page, let's pick out the one with the -2. So this will also be discussed on page 9, but in this problem, finding my vertex is the same. I look inside my parentheses and see a +4. So I think the opposite, because that must have been a -4 in order to get that plus sign there in the formula. So then my x movement is really a -4. My y movement is really my k, which is -2. It's whatever I see. So let's go plot that. Go to -4 down 2. That's my vertex. And now let's start with my quadratic movement, always 1, 1, 2, 4. But in this time, my a is -2. So my y equals a times x minus h squared plus k. A is -2. So now I'm going to multiply my y movements. This is what I do with my a. I multiply my y movements, because that's what's changing, by a factor of a -2. So 1 times -2 is -2. And 4 times -2 is a -8. Let's do this. So I'm going to go to my vertex, and I'm going to go over 1, down 2. And I'm now going to go left 1, down 2. So the negative makes it go down, and now the 2 has made it go down twice as fast. So now I'm going to do the 2, -8. So let's go over 2 and down -8. So 1, 2, 3, 4, 5, 6 off my graph for 2. And now let's go left -2 and down 8. 1, 2, 3, 4, 5, 6, and off the graph for 2. And now my graph is a little bit more narrow. My graph is more narrow. We also say it's vertically stretched. If you think of it getting more narrow because it's being vertically stretched. And that happens anytime my a is a number that is bigger than 1. In this case, I know it's a -2. That a being negative is what makes it go down. And that a being greater than 1 is what's making it more narrow. So it's kind of a combination of the negative and the 2 that's affecting my graph. Thank you.